multiplied, we need to check for their compatibility. Only if they are compatible.
Okay, we're just going to watch a couple minutes of this video. This is what we talked about yesterday at the end. What you should have done on page number 2, where we write the dimensions. We write the dimensions of the two matrix. We decide if they're compatible. So I like her animation. I think it'll help it sink in what we went over yesterday. And then, yeah.
Can they be multiplied? But wait, how do we check for compatibility? Not imply that B times A is compatible if, note that we are talking about A times B here and not B times A.
So you should already have this kind of written down.
A is the first matrix and B is the second. So the product AB is compatible if the number of columns in matrix A is equal to the number of rows in matrix B.
This is a review.
Yes, AB is compatible only if the number of columns in A is equal to the number of rows in B. Let's see a couple of examples. Can this matrix be multiplied with this one? We don't have to multiply, we just need to check the compatibility. Look at the rule again. AB is compatible if the number of columns in A is equal to the number of rows in B. Here the first matrix has one column and the second matrix has one row. The number of columns in this matrix is equal to the number of rows in this matrix. And hence, this multiplication is possible. Here's the second example. I encourage you to pause the video and...
We will. Okay, I want you to think about the rows and the columns. Think about the dimensions. So, Jose, what's the dimensions of that first matrix? 2 by 1. Yeah. Delta, what's the dimensions of the second matrix? Also 2 by 1. Are they compatible? No. So this is going to mess with your brain a little bit because yesterday these were perfect. I could have added them. I could have subtracted them. But now that we're doing multiplication, they are not compatible. Yeah, this kind of reminds me, have you ever done like a coding class and some kids like just get it and their brains like to code? Like when I do matrix, it kind of reminds me of trying to code. I have to pay close attention to the details. Okay, I'm going to go to the second video because I like it. It's going to go over...
Plus 2 multiplied. Given two matrices A and B, how would you find AB and BA?
Okay, please write down these two matrices. You don't have to write the A and the B or the equal signs, but please write down the matrix on the left and the matrix on the right. We're going to do this example with her, and then I'll do some with my voice. This is the only one we'll do with just her voice. But there's something about the way she can circle things that I think it's helpful. I don't know. I guess we'll find out. If not, the first part of the video is going to be kind of boring. Trying to make sure everyone's pencils are moving. Does anyone need a personal invitation to write this down? TJ, I invite you to write it down. Oh, you did it. Luke, mind your own business. Mind your own business. Okay.
Remember, matrices are not commutative. A multiplied by B may or may not equal B multiplied by A. Let's find AB first. Before we multiply, we need to check if they are compatible or not. Only if they are compatible, we multiply them, else we can't. How did we check for the compatibility? We found the order of each matrix.
We call that the dimension.
If the second
She
and the
calls
third
it the
numbers
order.
are equal. If yes, then they were compatible, else they were not. What is the order of the first matrix? It has 2 rows and 2 columns. 2 by 2.
You should write that
and
down.
What's the order of the second
I would write it
one?
above, though.
2 rows and 3 columns. 2 by 3. The second and the third numbers are equal. It means that the number of columns of the first matrix is equal to the number of rows in the second. This tells us that the two matrices are compatible for multiplication. But as discussed in the previous session, we could have just counted the number of columns of the first matrix and compared it to the number of rows of the second. Why is it a better idea to find the orders of the matrices? It's because this also gives us the order of the resulting product. The first number is 2 and the fourth number is 3. This will be the order of the resulting product.
When she uses the word order, we've been using the word dimensions. So those outside numbers, the 2 and the 3, are the dimensions of your answer. And it's very helpful to know that, which she'll demonstrate here in a minute. So please write down or circle or arrow or something that those outside numbers will give you the dimensions of the answer.
2 by 3. Now you know why finding the order of each is better. They not only tell us the compatibility, but also the order of the resulting product.
Or the dimensions.
We zoom out and find the product AB. We know that its order is 2 by 3, 2 rows and 3 columns. We need to find the elements in these 6 positions. Let me tell you the best way to multiply these two matrices. We take the first row of the first matrix and multiply it with each of the columns of the second matrix one by one. And then we do the same with the second row and so on. Solving it will give us a better idea. What will be the 1/1th element of the resulting product?
So I would suggest you're going to need quite a bit of space, so don't try to squeeze this anywhere. She uses ovals to represent the 2 by 3, and inside these ovals, she's going to put the multiplication and all of the problems. So as she goes through this, I'll follow along, write it down, I'll pause, and we can kind of talk about it. Bless you. I think of it like distributing. So she'll talk about this in a minute. She's going to take these top 2 numbers, the 1 and the 2, and distribute it. And it's kind of distributed strangely. The 1 will match with the 1, so the left and the top, and the 2 will match up with the bottom one.
It will be the first row of the first matrix multiplied by the first column of the second. It will be 1 times 1 plus 2 times 1. We multiply this number with this one and then this one with this. We have multiplied the first row with the first column. Now for the 1/2th element, we multiply the first row with the second column. We get 1 times 2 plus 2 times -1. This sum will be the 1/2th element. For the 1/3th element,
when she says 1/2th element, she means the first row and the second column. This first row here and this second column here. Okay, so again, it's the first, the left times the top, 1 times 2, and you add it to 2 times the -1, the right number times the bottom number. So see if you can follow that pattern. You may not be ready yet, but see if any of you can find that pattern. So we're still focused on the 1 and the 2, and we're going to multiply it by the 0 and the 3. And what symbol goes in between them? Addition, a plus. So go ahead and try to write it out. See if you've figured it out. It may only be a few of you yet. So top row of the of matrix A, third column of matrix B. Does anyone think they have it? Mm-hmm. What do you think it is, Tristan? Perfect. Perfect.
of the resulting product, we multiply the first row with the third column. We get 1 multiplied by 0 plus 2 multiplied by 3. We are done with the first row. We have multiplied it with each of the columns of the second matrix. There are 3 more elements we need to find. To find the element in the 2/1th position, we multiply the second row with the first column. We get -1 multiplied by 1 plus 0 multiplied by 1. Why don't you try finding the elements in these 2 positions? Pause the video and give it a shot.
Good. Pause the video. Okay, we did. So we're done with this top. See if you can. I get nervous about saying distribute because we're not multiplying everything by everything. It's just 2, -1 times 2, plus 0 times -1. So see if you can do it on these next 2. Yeah? Mm-hmm. Exactly.
So it'd be like this times that, this times that, this times that, this.
Mm-hmm. All right, let's see how you did. Oh, she paused with us.
For the 2 2th element, we multiply the second row with the second column to get this. And for the 2 3th element, we multiply the second row with the third column to get this. It's quite easy to remember. 1 1th, first row, first column. 1 2th, first row, second column. 1
1
3th, first row, third column, and so on. This was the part we had to understand well. The rest is just plain simple calculation. Let's see what we get as the product. This will be 1 plus 2, 3. 2 plus minus 2 will be 0. 0 plus 6 will equal 6. Minus 1 plus 0 will equal minus 1. Minus 2 plus 0 will equal minus 2. And 0 plus 0 will equal 0. 2 rows, 3 columns.
Did everyone get that part? Because I'm going to go out of this in just a sec. These are quite small numbers. You may want to grab a calculator. I don't know. Her numbers are small. The biggest one is 6. Hmm?
Sorry, what are ours?
Okay, well, let's go look. Definitely undo that.
Okay, then do I just add them together once I have them?
What is going on here? Okay, I don't know. This won't let me refresh it. All right, let's look at the board for a minute. And it's already written all over because it won't let me erase the red stuff only. So fun. All right, looking at this, this is the part we did yesterday. We write down the dimensions. If the two middle values are the same, they are compatible. And the A and the D give us the dimensions of our answer. The outside numbers give us the dimensions of our answer. So with my other class, we went through these ones. It won't let me erase just the red. It erases everything for some reason. Okay, so I just said to them, is this one compatible? Yes. What are the dimensions of the answer? 3 by 2. 3 rows, 2 columns. Not compatible. Not compatible for multiplication. Compatible. What are the dimensions of the answer? 2 by 2. 2 rows, 2 columns. Okay, hopefully I can... What the heck? Why isn't it letting me do this? All right, I don't know. Write down 3, -1, 4, 0. Was it like that? I guess it doesn't matter. It'll be our own problem. I think it just thinks it is. Oh, I've done that. Some of them do. I think this one's a dry erase board. I know how to get it off, though, if it's not. Okay, please write down this one. We'll do this one together. So in your notes, write this one down.
We have like a drop-down sheet for dry erase on that in middle school, and it did not come off. It just created like this giant like.
That is horrible. All right, so we start out. You should have done this yesterday. That's why I wanted to give you, it'll save you a little bit of time. Martha, what are the dimensions of this matrix? And I like to write it up above so it leaves plenty of space below to do my work. Levi, what are the dimensions of matrix B? Sydney, are they compatible? What are the dimensions of the answer? 2 by 3. So this tells us they're compatible. So I'm going to have you do this method. If you find a method that's different than you like better after this problem, that is fine, but I do want you to stick with this one. So we have a 2 by 3. Please draw your ovals. There is something about this that'll help your brain stay organized. And again, after this one, if you find a slightly different way that works better for your organization, That's okay, but this has worked for like 95% of us. Okay, to get started on multiplying matrix, we focus first on, she called it 1, 1, so row 1 and column 1. And I'm going to do 3 and the negative 2. So 3, I don't do the big X. She was like, times. I don't do that. I haven't done that in a long time. I do the parentheses to show multiplication. And then my negative 1 and my 3 I'm adding. My seating chart. Okay, I'm going to take turns calling on some of you to help us know what to put in these other cells. That's not even this class. My papers are really unorganized. There it is. And I'm just checking for understanding. So if you're not quite ready to say your answer and do it on the board, just let me know. We'll pick on someone else. Okay, Paxton, we are done with the first column. We're moving on to the second one. What are the numbers that we would put in our oval? Okay, I'll come back to you. Grace, I'm still focused on the top row and the second column. What am I multiplying together? So left and top, right and bottom. That's kind of a pattern. Okay, we're moving on to the third one. Logan, what am I multiplying to get these numbers?
3 by 6.
Plus. I meant to color code those. I definitely didn't do that. Okay, wonderful. Kate, you ready to help us with the next one? So we are done. Once I get done with this first row, I cross it off. It's pretty final. These ones I have to go through again, but I don't ever use those two numbers again. So Kate, I'm with 4 and 0, and the first column, what am I multiplying together? Plus? What's 0 times 3? I might just write 0. Just going to save myself a second here. All right. Tyson, what about in this cell? So I'm here, and I'm here.
4 times 0.
Okay. Next one, what are we going to put? So again, I'm at the second row, third column.
4 times 6.
Plus, oh, I hate when I put parentheses right in the middle of my problem. Okay, now I just need you to be 100% honest. No one's going to turn around and look at anybody. Raise your hand if you have no idea where we're getting these numbers from. I just kind of need to know. It's okay if you're not quite sure yet. We'll do another one. Okay, so from here, she was like, this is the easy part. You just do your multiplication and your addition. So if you need to put them into calculator, that's fine. Most of these are pretty small numbers, so we're doing 3 times negative 2 plus negative 1 times 3 is negative 9. 4 times negative 2 is negative 8. Negative 8 plus 0 is negative 8. It's from here, because it just is the screen. Like, you can't see me in the video. It's a webcam, so I could teach like that if it was online, but no one's ever used those, I don't think. They're not. 0 plus negative 5. 0 plus 0. 18 plus negative 1. You get the gist, right? Okay. I would like to do some examples, but from the worksheet. So if you don't have your worksheet open, please get it out. And we will pick a couple to do together. And I will show you, I don't know if I want to call it a shortcut, but kind of. We're going to look at number 3. All right, Jeremy, what are the dimensions of this matrix? And you guys, most of you should have done this yesterday. A 2 by 3. Zara, I skipped you. Addie, what's the dimensions of this matrix? Zara, are these two matrices compatible for multiplication?
Yeah.
Yes. And Alyssa, what will be the dimensions of my answer? 2 by 2. Does it seem weird that your answer will be smaller? It just seems weird. So use the ovals. A 2 by 2. That didn't take very long. It's a great method. Okay, I'm going to do this first one because this is different. We haven't done any that are 3s yet. We are focused specifically on this top row, and we are multiplying it by the left column. And they match 1 with 1, 1 with 1, 1 with 1. So 3 times negative 5. After I did 2 the other way, I now think in my head, what is 3 times negative 5? If you like to write 3 times negative 5, right? If you like to write it out, you can. I'm going to try to do some of that in my head. Sarah, I think I skipped Jeremy. Or Andrew. Andrew, what do I do next? Four times 3. Sarah, what's next? So I'm still on the... There you go. 0 times negative 5. Do you see why I couldn't teach it this way? I would lose everyone. Like, you have to see those numbers, but you won't, once you get it, you won't want to probably write out every single problem. You'll probably do it in your head. Okay. I had a couple students rewrite it flipped. All right, let's go to the next one. So we're done with this. We are now focusing our attention on this second column, still the first row. So Luke, what am I going to put here? Okay, so top row and second column, what are the first two numbers I pair up? 3 times 2. What are the second two numbers, Luke? 4 times 2. Emery, what are the next two numbers I pair up? You're welcome to write 0 times 4. Some people like that better. Trying to give you some different options. Do any of them? One by one. I guess you just have one answer. Okay? Just do this. You'll do the same thing, but it will just be one. It'll just be one thing like this. It'll be like this time. Like it'll be one here and one there. So once you get done with something like that, it'll be done. The whole problem will be done. Just try it. I'll come help you in a minute. You're the one working ahead. Okay, we're done with the top row. We're going to do the bottom row, and we're back to the first column. Lauren, what numbers do I match up for the second row and the first column? I'm going to multiply them in my head. And I want Jose. 2 and 3 plus Ambrose, what's my last numbers to pair up? We're still on the first one, sorry. There you go. Okay, now I'm officially done with this one. I'm still on the bottom row, moving on to the second column. Macy, what are my numbers I'm going to multiply here? And I'm doing that in my head. Tate, what's next? Which is 4. Ashlyn, what's my last ones I pair up? 5 and 4. And then you're adding. Whew, that's a big number. Negative 4. Did I even do that right? Oh. I did this one earlier. Raise your hand if you need me to do one more as a group on the board. Okay, which one do you want us to do? 4? Okay, we'll do 4. Don't do 4. Let's do 6. No one got to 6 yet, did they? Well, Miles doesn't need another one. He's on a roll. I'm sure he's not going to sit here and watch me on this one. He's just cruising. All you computer programmers are like, done. The patterns. If you can code, you definitely, this makes sense to your brain, I have a feeling.
I have a feeling.
Okay, we left off with, I think I've called, no, I left off this side of the room. CJ, what are the dimensions of this matrix? Tyler, what are the dimensions of this matrix? A 2 by 2. They are compatible, and the dimensions of my answer are a 3 by 2. So a 3 goes this way, and the 2 goes this way. It is a 6-pack. I should have been an artist. Just kidding. Okay, let's start multiplying them. We are going to focus on row 1, third time's a charm. Column 1. Mm-hmm. All right, Bradley, what numbers am I matching up for this multiplication cell? So what are the numbers that will match up then? So I got a -5, which is -30. Okay, now we're sticking still with the same top one, but we're moving to the second column. So Miles, can you help us out with top row, second column? I know. All right, I'm done. It's pretty official, so I just cross it off. I'm focused now on the second row, back to first column. So Martha, what are my numbers that I'm matching up during that multiplication? Okay. Turley, what now? What now? And which one?
-6 times 6.
Okay, I want you to help out. So we're here. Oh, wow. Moving the arrow. We're on the second row, and we're on the second column. So there and there. Yes. And the last one, Miss Jetta, what am I doing? I'm moving on to the third row, and I'm back to the first column. And the last one, -5 times the 4, -3 times the -4. And I think we're good with adding. Does that help? I hope you're not being shy. If you are confused, now is the time to ask for another problem.
Number 8.
Okay, so the steps for this. Number 1, which you should have done this yesterday, write down the dimensions so you can check for compatibility. So check for their compatibility. And it's those two middle numbers, like okay, will look like that. And then find the dimensions of your answer. Which in this one would be A by C, and then do your ovals, okay? Once you get it all set up with your ovals, We are focused on row 1 in your first matrix and column in your second matrix. And we go from column to column to column to column. Then we go to row row 2. And we start over again on matrix B with the columns left to right. I don't know if I spelled that right. Okay, I'll come around. I only have 4 answers.